Welcome to a tutorial on the 8085 arithmetic operation instructions. Okay, so first of all, we're going to start with the few arithmetic instructions that are very important. So what we've done here is that we've just included the basic types of arithmetic operation instruction that you need to know beforehand. Okay, so we're going to start with the addition instructions. Okay, now let me just tell you that the 8085 can perform arithmetic operations. That's quite clear to you all. Now there are two types of addition instruction that it can basically perform. So one is known as just simple ADD, okay, and the other one is known as ADI. Okay, now these two instructions, although they perform the same arithmetic operation, but the way in which they are used or they are declared in a program a little different. So we start here with the ADI instruction first. Now, ADI actually stands for, let me just tell you over here, ADI, it just stands for add an 8-bit data immediately with the data present in register A or the accumulator. Okay, now let me just tell you, all the arithmetic instructions that you're seeing over here, they involve, they have one thing in common, that's the involve the accumulator. Okay, so all these arithmetic instructions, they involve the accumulator, okay, or register A, and this is very important because whichever the data you need to actually execute or perform any kind of arithmetic operations on it, you need to store that particular data in the register A, also referred to as the accumulator. Okay, so now as I was talking about the addition instruction over here, that's ADI, it just means add immediately. Okay, now its main operand is basically an 8-bit data, or any 8-bit data can be its operand. So let me give you an example over here. Let's say if you now what this instruction basically does is that it just adds an 8-bit data with the data that is present in the accumulator currently. Okay, so let me give you an example. Let's say we have the register A, okay, storing let's say a data of it just stores a data of, let's say, 0 to H. Okay, that's a hex data. And now, if you would write an instruction, ADI, or rather, let's just do it over here. If you'd write the instruction somewhat this way, ADI, and as the data, you just put another variable over here, like for example, let's say, A5H. Okay, let's say you wanted to add the data present in the accumulator with the data, 8-bit data that you're supplying right now instantly. So what it does is that it just instantly adds the accumulator's data with any 8-bit data that you just supply through your program. Okay, and this all happens instantly. You don't need to store this data beforehand in anywhere. Okay, so whenever you just declare this instruction in your program and after it just gets executed, what happens is that, these two data bytes, they just get added. Okay, so if I might add these two data bytes, so for 0, 2, we would have a binary code of 4 zeros and 2010. Okay, and then for A5 we'd have a code of, let's say, 1010 and then 0101. Okay, now if you'd go forward and just add them, you'd have this particular result. Now if you divide it into groups of 4, then you'll see this entire binary code actually corresponds to a hex value of A7H. Okay, it just corresponds to a hex value of A7H. Okay, once you've just added these two data. Now this particular data, that is A7H, after this instruction ADI is executed, will be stored in the accumulator itself. So there you go. So what this instruction basically does is that it just adds an 8-bit data instantly with the data present in accumulator. Okay, and then the result of the addition is stored in the accumulator itself. So now the accumulator doesn't have the previous data that was 0 to H, but instead it now has the result. Okay, so that's quite a simple addition instruction. Now we're moving on to the other type of addition instruction that we are supposed to learn over here. That is ADD, or add instruction. Okay, Now the add instruction is just different from the ADI instruction in a way that it basically works with registers. Okay. Like for example, if you need to execute the, if you need to add 2 data bytes, although it just adds 8-bit data, but any kind of data basically. Now if you need to add 2 data bytes, that's 2 8-bit data, using the add instruction, okay, then you need to store one of them at a specific register while the other remains in the accumulator. So what this instruction does is that it just adds an 8-bit data to a data present in the accumulator. So as this particular description points out, that it just adds data in a register or memory location. Okay, it can even do that with data in the register A, that's the accumulator. So that's why we have all these registers starting from A, and even it just includes the M also, which corresponds to a memory location stored in the HL register pair. So let me just give you an example over here. If you'd have, okay, let's say the accumulator currently, that's the register A, is storing a data of what? Okay, let's say 2 FH, okay, and let's say we have another 8-bit data loaded in the register B, which is nothing but let's say it could be what could it be? It could be 0 3H. Okay, so now if we just go forward and add them, then for 2FH we can basically have a binary code of 0010 and then all ones, and for 03H we'll have a binary code of all zeros and 0011. Now if we just go forward and add them up, we're going to get a result of 32H. Now once again, the result would get stored in the accumulator immediately after the instruction is executed. And in order to do that, okay, in order to add this the data in the register B with the data in register A, you're supposed to write the instruction somewhat this way. Well, it's going to be something like ADD and then B. So this instruction means add the data byte present in the register B with the data byte present in register A. Okay, and it also stores the result in register A by default. Okay, now similarly, if you'd have a particular memory location loaded in the HL register pair, for example, let's say I just describe it right over here. Let's say you had the HL register pair. Okay, now if you had the memory location of, let's say 20FFH, okay, loaded in the HL register pair, and now you wanted the data byte present in this particular memory location to be added to the data byte in A. Okay, and let's say at this moment the register A, it is storing, okay, the register A at this moment, let's say, is storing a data byte of, let's say, what could it be? Okay, B2H. Okay, now let's say the data byte at this particular memory location is nothing but 1A. All right, 1AH. Now you want this particular data byte at the memory location 20FF to be added to the data byte present in the accumulator. So what do? You just load this particular memory location in HL register pair, which is already done before, and you write the instruction instead, add M, and that's all. And this basically will add the data byte 1A to the data byte B2 that's present in the accumulator. Okay, so after they get added, okay, so this would generate a result of CCH that we can see over here, and once again, like the previous examples, it will get stored in the accumulator by default. Okay, so that was the the addition instructions, the ADI and the add instructions basically. And we might want to make a little change over here. It won't be a register, but it will also be a memory location. Okay, so yeah, there you go. Now that's better explained. Okay, so that was the addition instructions, and now we're gonna move to the subtraction instructions. Okay, now in the subtraction commands, I mean the instructions that are there for subtraction are basically, well, SUI and SUB. So for SUI is, well, it is similar to that of ADI, okay, where ADI means add immediately, okay. SUI means subtract immediately, okay. And we specify an 8-bit data that we need to add immediately or instantly to the data in accumulator. Similarly, for SUI instruction, we also supply an 8-bit data that we need to subtract from the data content of the accumulator. So as this says, I mean, as a point, or the description over here says, well, subtract immediately specified 8-bit data from data in the register A, that's the accumulator. Okay, so you have a data, let's say the accumulator, okay, this is accumulator, and it has a data of, let's say, B3H, okay, and you write an instruction SUI, okay, and over there you just specify 5AH. So now what you want to do, or rather what do you actually imply by this instruction, is that subtract immediately from the accumulator data this particular 8-bit data that I have specified over here. Okay, now this instruction actually means that we're supposed to subtract this particular 8-bit data, that is 5AH, from the data content in the accumulator, that is B3H. So we need to perform a subtraction operation of, well, B3H minus that of 5AH, which would result in a result, I mean, it would just, result in a hex number of 59H, and that would once again be stored in the accumulator, that's the register A, once the SUI instruction has been executed. So it can be any 8-bit data with the SUI instruction. And well, after that, the sub instruction that we have over here, well, this just works with the registers and the corresponding memory locations, much like the one much similar to that of the ADD instruction that we had seen previously. Okay, so like the ADD instruction, the sub instruction will actually it just includes all the registers, okay, starting from A to L, okay, and it also involves this particular variable M representing a memory location that could possibly be stored in the the HL register pair. Okay, so let's just give an example over here similar to what we've just seen beforehand. Okay, now if we were to perform the same operation using the SUB instruction, then it would have changed, the way in which we need to declare the statement would have changed. Okay, so let's say this particular data, okay, this 8-bit data, that is 5AH, is stored in the register B currently. So let's say register B stores this particular data, that is 5AH, and well, the accumulator currently is storing the data B3H. So similar to the previous example, I'm just giving the same over here. Okay, so what we do is that we just declare the we just write the program code this way. We write here, well, sub, okay, and give the name of the register B. Okay, since we are supposed to subtract the register B's data, okay, the 8-bit data present in register B from the one present in register A. Okay, so that way we would have the same result that we got in the previous instruction, that is SUI, and that you can see over here, that's 59H, and it gets stored in the accumulator itself. Okay, now similarly, if we assume the entire thing somewhat this way, that let's say I'm also going to give you a memory location example over here. Let's say the HL register pairs, okay, they contain a 16-bit data that corresponds to a memory location. Let's say 30BBH. Okay, so yeah, this is possible, not a problem. And let's say that in the memory location 30BBH, okay, there is a particular data of let's say E0, or rather let's just take this data, a simpler data, that is C7, okay, H. Now we want to subtract this particular data from the accumulator data content, which is actually FFH currently. Okay, so in order to do that, what we do is that we just write the code sub m. Okay, we would write here sub m, where m corresponds to the memory location 30BB that is currently stored in the HL register pair. So this is m. Okay, now after the sub m instruction gets executed, okay, the accumulator is loaded with a result, with a data byte of 38H, okay, which is actually the result of the sub m instruction, okay, and that just gets stored in the accumulator by default. So this is the result that we got over here, and well, this just gets stored in the accumulator by default. So this is how you can just work with a memory location using the sub instruction. So they are pretty much similar. Okay, now it's worthwhile mentioning here that the SUI is basically a 2-byte instruction. Okay, so this is a this is basically a 2-byte instruction, whereas SUB is a single byte instruction. And similarly, the addition instructions that we got over here, ADI, would also be a 2-byte instruction, okay, because it contains the command as well as the data. And ADD, on the other hand, is a single byte instruction. Okay, now from here onwards we move on to two other arithmetic instructions that are very important while setting up loops and conditions. Okay, so we're gonna check them out right over here. So enter the increment and the decrement instructions, okay, and their corresponding opcode and operands are given alongside, as you can see over here. Okay, now you need to keep in mind that the INR and the DCR, okay, which are the corresponding opcodes of the increment and the decrement instructions correspondingly, okay, there's operand, okay, the operand that they'll be basically acting upon are any of the registers starting from register A through to L. Okay, so if you would need to actually increment the contents of a particular register, then you can just write the INR instruction over there. Like, let's say for example, let's say the register C has a content of, let's say, 00H. Okay, and if right at this moment, if we write the code of, let's say, INR C, then it would just result in incrementing the data byte of the register C by 1. Okay, and now the register C has the content of 01H. Okay, now you can see that how the content of the register C has been incremented by 1. So this is exactly is summarized by this particular point over here. So it just says increments data in register C by 1. And now if we would execute the DCR statement instead, okay, and currently we know that the register C is storing a data byte of 01H. Now if we would write here DCRC, okay, then that would cause the register C to so now if we just go forward and execute this particular statement, if the 8085 if it just goes to execute this particular statement, then once again C's current content, that is 01H, would be decremented by 1. So therefore the register C right now has a data byte of 00H. So you can see that how the content of the register C has been decremented once again by 1. Okay, so both these increment and decrement instructions, they increment and decrement the content of a particular register by 1 respectively. Okay, so in the description it'll be much more suitable to write the specified register in place of the register C, because it can well affect the data content of any register. You just need to change the operand register right over here, and then you'll see it affecting it correspondingly. Okay, now all these changes, all these instructions that we have just discussed over here, whenever they're used to execute data present in the accumulator, all of them affect the flag registers, or more precisely the flag bits in the flag register. Okay, So therefore, we've just thought of, showing you all how the flag register bits get affected, or by each of these examples. I mean, each of these arithmetic instruction examples that we've just exhibited over here. So for this particular example, this is how the bit pattern of the carry flag bits get affected, and so on for the rest of the examples that we've just shown you all. Okay, for each and every instruction concerned. Okay, but only in the case of the increment and the decrement instruction, let me just tell you, the carry flag is just exempted. Okay, the carry flag is not affected. Now for both of these instructions, okay, the carry flag is not affected. Okay, because these do not generate any kind of carry, so carry flag is not affected at all. Okay. Now, like the previous instructions that you saw over here, the increment, the INR and the DCR are both 1 byte instruction, or you can also refer to them as single byte instructions, okay, as indicated over here. Alright, so that was all from this tutorial on the arithmetic operation instructions. And also note the fact that all these instructions, they basically operate on 8-bit data. So we're concerned with operation on 8-bit data, so that's why we've just shown you the arithmetic instructions that operate on a byte of data only. Okay, so from this tutorial we'll henceforth take your permission to bid goodbye, and we hope to meet you next in the forthcoming tutorials. So till then, just a short goodbye for now, and thanks for watching.